Welcome to Application Security Weekly. I'm Adrian Sanabria, standing in for Mike Shima this week. He'll be back with you next week for episode 157. This week, we kick off the show with an interview featuring Clint Gibler, head of security research at R2C. Clint is with us today to discuss scaling your AppSec program. In the news segment, Adrian and John will discuss Visual Studio Code's workplace trust, injured Android and insecure mobile app, Microsoft accidentally signed driver with rootkits. That was a fun one. The NSA funds a new sister matrix to attack called Defend. And ransomware. Maybe it's you, not them. Stay tuned for all this and more on Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Are you looking for a solution to protect your web apps against the most business-critical security vulnerabilities? Unleash the power of automated ethical hacker knowledge with Detectify for continuous coverage and relevant security vulnerability findings. Upgrade your web app security with speed and scale and start a 2-week free trial at securityweekly.com/Detectify. Go hack yourself. We discuss application security a lot on this show, and we know that the implications for code security have become even greater as cloud adoption accelerates software development. Shift Left bridges the gap between security teams and developers to find and fix vulnerabilities accurately from the source. Shift Left Core is an innovation in code security with industry-leading accuracy and speed. It combines next-generation static code analysis, intelligent software composition analysis, secrets detection, security insights, and contextual developer security education in one easy-to-use platform. Learn more and create your free account at securityweekly.com/shiftleft. Whether you need to manage bots, protect cloud applications at runtime, stop form-jacking attacks, or secure your web applications and APIs, only Imperva offers a unified solution to protect from edge to application and data in one tool. Imperva helps you achieve more, save money, and become more efficient with fewer security vendors needed. Start a free trial today to easily protect your apps and website with Imperva. Learn more at securityweekly.com/Imperva.
Welcome to Application Security Weekly. This is episode 156, recorded on June 28th, 2021. Providing literal moral support and helping me not mess up too badly is John Kinsella. How are you, John?
Adrian, good to see you. How you doing?
Pretty good. It's I've only been on the show a few times, so I might lean on you a little bit.
I'm more than happy to have you. It's going to be a good time.
Absolutely. So Security Weekly is more than happy to announce that we will be at InfoSec World 2021 in person, October 25th through 27th, 2021. This year, our annual partnership with InfoSec World is extra special as we are both business units under the Cyber Risk Alliance brand. Or if you ever hear us say CRA, that's what we're referring to. What does that mean for Security Weekly listeners and InfoSec World attendees? You'll get to see and hear from many of us at the event, and you can save 20% off on your World Pass. Visit securityweekly.com/ISW 2021 to register using our discount code. In our July 14th democast at 11 a.m. Eastern Time, learn how to reveal and protect your entire attack surface. Then join us July 15th at 11 a.m. Eastern to learn how a thoughtful approach to SASE, I say SASE, some people say the letters out, but I love that it sounds like SASE, can improve security and enable scalability. Visit securityweekly.com/webcast to register now. If you missed any of our previously recorded webcasts or technical trainings, they are available for your viewing pleasure at securityweekly.com/on-demand. And both me and Paul will be on both of those. All right. Joining us today, Clint Gibler is the head of security research for R2C, a startup working on giving security tools directly to developers. Previously, Clint was at NCC Group, a big consulting firm I think most people are aware of. But a lot of us know Clint from his very popular newsletter, TLDRSec, which I know a lot of us use to keep up on things. Welcome to the show today, Clint.
Hey, Adrian. Thanks so much for having me. Excited to be here.
Awesome. Yeah, so just help me understand the relationship between R2C and SemGrep.
Yeah, that's a good question. So R2C is a San Francisco-based startup, and SemGrep is an open source static analysis tool that we're building. Yeah, I don't know if you're aware of this, but actually the origins of SemGrep actually go back a while. So the creator of SemGrep, Yoan Padalu, actually was the first program analysis hire at Facebook. And there he built a number of security tools, one of which was SGrep, which was used to enforce a broad variety of secure coding standards. He ended up leaving Facebook and then a number of years later joining R2C. And then during a Hack Week project, he took SGrep and sort of started running with it again. The company really liked it. And it turns out a lot of other people really liked it. So it got rebranded from SGrep to SemGrep. And that's a tool that we've been continuing to push forward for about the past year and a quarter or so. Yeah, so R2C is the company, SemGrep open source tool, and origins date back to Facebook days, actually.
It's sort of awesome how a project, I mean, something that's been around, obviously, and it's used in the past, but like, it's funny, I'm stumbling because I want to say one of us goes and works on something for a weekend, but let's be honest, it's been a long time since I've had a weekend like that. But, you know, someone gets, you get excited, you get focused, you're working on something for a weekend that like actually is something you're passionate about. And next thing it becomes a significant part of a company. That's really cool to see.
Actually, a funny thing, a funny anecdote is so every we try to have hack weeks about once a quarter, and basically either individual people or small teams group up and like try to rapidly prototype something. And so Yoan's project, that sort of fateful quarter, was SGrep or SemGrep, and the funny thing is he actually didn't win. Which he likes to constantly remind us, as it's now sort of like one of the primary things our company is working on. Someone else won that week. So he's like, my Hack Week project didn't even win. And now it's like sort of the main thing we're building.
So that means another product coming in the future, right?
Yeah.
Nice. So it seems like the pretty typical like open source as a product, kind of model here where the paid plan gives you support, gives you a single sign-on, gives you an API, and depending on how much support you need, you've got a few different tiers that you can add on there.
Yeah. Basically, the idea is like one thing we try to sort of walk the line quite carefully is for some tools that are sort of like open source, but then also commercial, sometimes the tool can feel the open source version can feel a bit like crippled or like not like a fully fledged tool, and you need to sort of pay to get something reasonable. Philosophically, we want to make like the best standalone tool possible, such that if you are like an individual security researcher or a security consultant or a person who's just like wants an awesome standalone security tool, we're trying to like make SemGrep CLI like as good as possible and not really hamstring it in any way. But what we found is a number of companies who were like, oh, this tool is really nice. I wish that I could run it on hundreds or thousands of repos. And I want, I want metrics. I want a dashboard. I want sort of data retention. I want to see trends over time. I want to be able to orchestrate like which repo gets scanned with what. Like, here's all of my Flask repos, so I want to make sure I run the Flask rules. There's some, say, Kubernetes rules that I want to run here. And basically what we try, and like integrations with like Slack and email and others. So basically we were like, okay, for individual security professionals, let's build the best open source tool we can. And for people who want to run this tool at scale across an enterprise, like what are those business problems that they have? And then we try to solve those in a sort of SaaS dashboard, which actually has a very generous free community tier as well. So there are actually a lot of medium-sized companies using the community tier that like get a lot of value and don't even have to upgrade. But there is some additional value, obviously, for having a paid account. But that's how we think about it.
So, for a long time, I remember having conversations with Josh Corman, back in his rugged manifesto days. the dream was that the tool would be, the right thing to do would be the easy thing to do, and the solutions to a lot of our security problems would be right there, where we're building technology, where we're building infrastructure, building code, and things like that. It seems more and more like we're getting there. Like we've got tools that encourage that, enforce that. How close are we getting to a reality there, or what the reality should be?
Yeah, that's a really good point. I do think you've called out like a very interesting shift in sort of technology and security in general. I think if you look sort of historically, maybe 10, 15, 20 years ago, there was this massive focus on how do we find all the vulnerabilities? How do we build tools that can find more and better vulnerabilities? But I think what I've seen in the past, say 5 to 7 years, is this sort of realization that like you can't find all the bugs, like even with an infinite pen testing or infinite tool budget, you just can't find everything. Just fundamentally, there's always going to be more and more issues. So what we see at, say, like Facebook, at Google, and Microsoft, and Slack, and DocuSign, and Dropbox, and Netflix, and like all these companies, like what their sort of forward-thinking security teams have started doing and have continued doing is like, okay, let's make the secure way the easiest way by building libraries, services, and infrastructure that we provide to development teams, such that if they use them, given classes of vulnerabilities just can't happen in the first place. So you don't need to find them because they just can't happen. So for example, one company, I think Google, wrote a nice white paper or called this out in their book, where they wrote a sort of a SQL wrapper library that they require everyone to use. And if you use it, the only interfaces they expose are sort of parameterized queries. So SQL injection just can't happen. Or for example, Facebook with React, they have dangerously set inner HTML, which disables output encoding, thus enabling cross-site scripting. But basically, if you do almost anything else, you just can't do that. So that sort of idea of like, how can we make the default way secure and easy, and then just tackling different classes of vulnerabilities across your org, I think it's very powerful, and that's what I see a number of companies starting to adopt. So it's not necessarily easy, but it's super high ROI if you can do it. And I think it's going to be easier.
It's interesting the way you describe that, though, because we've seen the pattern for the last, call it 5 years, where some of the major frameworks, like the Reacts and the Angulars, and some of the .NET stuff, they've, from a framework point of view, been setting better defaults. And I think that's something which can be really well leveraged by the general population, right? It's you don't have to have that security team which is doing it for you. It's really interesting to think about from the point of view what you just said is not so much trusting the upstream to do it, but if you're lucky enough to have a security team that can help set those defaults and sort of force you through think about bowling, right? What do you call them? The guardrails in a bowling alley. How can those who don't have a world-class security team really like that sort of benefit from that?
Yeah, you give a great example. Web frameworks, I think, have been a lot better. I remember in Rails 2 or 3, basically whenever you were output, you needed to like turn on output encoding by doing like, I think, H and then whatever the variable was. So basically, if you're including variables like 100 times, you need to remember to call this secure helper function like 100 times. And if you miss one, it's cross-site scripting. But instead, going forward, frameworks, I think, are being more opinionated about like, this is the way you should do things, so that everything is output encoded by default. And instead, you just have to include a little thing that says like, disable output encoding here, so you can just like grep for those, right? Like these are the dangerous places. So I think overall, libraries and frameworks are becoming more secure by default. Definitely, like new things tend to have more edges. Like when Kubernetes first came out, there's like a bajillion sharp edges. But I think over time, like managed Kubernetes is getting a little bit easier, fewer sharp edges. So I think modern frameworks aren't going to help you with everything, because some of the stuff is going to be custom to your organization, and maybe you need a bit of security engineering resources internally. But ideally, overall, the industry is getting better because of, as you pointed out, sort of frameworks are getting better. But yeah, I would maybe throw a little shade on security people, including myself in general, because, I think what made web security much better is not necessarily us like pen testing and finding all the bugs, but rather frameworks becoming better.
Yeah, I mean, it's one of my favorite topics is pointing out how just DevOps, the move to cloud and the need for performance and reliability, doing so much for security without really intending to. It was just, a nice side effect, I feel like.
Yeah, totally. And this focus on iteratively, like how do we have rapid iteration cycles? How do we get feedback? How do we like understand how things work end to end with lots of like telemetry and logging? I think that's been hugely valuable for security, which we just sort of got to tag along and get those benefits, I guess.
Yeah, immutable infrastructure, disposable infrastructure. I mean, the fact that code doesn't stick around very long in production. So just age of assets going from years. The whole cattle and pets thing going from years to maybe a week at the outset.
I think it'd be interesting to see a breakdown for custom applications, in-house applications. Are we now seeing more of those vulnerabilities coming from those more modern immutable apps, or is it coming from the legacy stuff? Because as you said, it's with a modern one, it's if you can even find the vulnerability, is it going to be there for more than 10, 15 minutes, depending on how you're restarting or launching, or if it's serverless. But if it's it's still the EC2 instance, which has been running the same code since January, it'd be interesting to see if there's what the breakdown is between those two, where issues are coming from nowadays.
Well, and there's vulnerabilities, and then there's vulnerabilities that can actually cause you pain, that actually matter. I think that's part of the problem.
I think that's actually a really interesting thing, though, because I don't want to speak for Clint, but you and me, Adrian, probably when we've done stuff in the past, and I suspect Clint too, we've frequently said literally what you just said, which is, oh, that's a little tiny vulnerability. No one's going to hit that in code. And there's a story. I'll see if I can find it for the news that came through over the weekend, where someone's talking about just that. And I think if you look at some of the larger, I'll say security activities we've seen over the last year, it's not so much a malicious user driving a truck through a big open window. The attacks are becoming more finesse and more targeted. So what used to be something you could say, oh, no one's going to hit that, people are now taking the time and resource to actually find those and have a bigger payday. So a little more research is what I'm seeing. And then, so instead of doing so much of the spray and pray, which they're still doing, I think they're getting more bang for the buck, unfortunately, out of a little more targeted attack. I don't know if you'd agree with that, Clint, or...
Yeah, that's a good point.
And you can say I'm wrong.
I'm trying to think. Like, I don't necessarily say I've read enough things thoroughly enough to have like a sort of data-based opinion on that. But I would say maybe like anecdotally, I feel like a lot of the breaches and big compromises that I've seen recently have often been like public exploits or just like out-of-date things, and not necessarily artisanal, bespoke, custom O-days for a company. But there's like, this VPN software has some RCE exploit code gets published, and then there's people who are just like, okay, scan the entire internet to see like where all of these are. Because I don't know. I guess like from an attacker point of view, you want the most bang for your buck. To your point, so if there's out-of-date software with known exploits, or you can easily reverse engineer an exploit for those, then that's a lot easier and applicable to more targets than a vulnerability specific to one company. So I feel like, I don't know, I want to say 80 to 90% of the things I've seen, like the exploit itself may be very complicated, but I feel like it's sort of a known thing that applies to multiple companies rather than a one-off. Like, I don't know, like Juniper or F5 or things like that.
I think the data backs you up too there, Clint. If you look at the Verizon DBIR, first of all, we went from something like 7% of breaches had vulnerabilities related to them, down to 3%. And the actual raw numbers went up, but other types of breaches just got so much bigger, that the relative percentage actually went down. But Yeah, and we found out, the way a lot of extortion cases work is, if there's a remote code execution bug in WordPress, you can be pretty much guaranteed that folks will be scanning the entire internet for it, pretty soon after, a proof of concept or something like that is released.
Like an hour later. Yeah.
I don't know what the actual time frame is, but yeah, you should consider that, pretty important thing. But then, bugs that are specific to you, yeah, it's a whole lot less common, for somebody to, develop something specifically for you. And maybe there's some exceptions there, like SQL injection.
But at the same time, think about it, right? This Application Security Weekly. So while for this particular subsegment of InfoSec in general, a certain percentage of the vulnerabilities are going to be in the libraries that we're using, which are common. But I think a lot of the issues which our listeners are attempting to find and mitigate before the bad guys is that the SQLi or the cross-site scripting, or these are the things where we need the secure defaults, as Clint was talking about, right? So there's obviously the bigger things which we're going to care about, but I think it's the more surgical strikes is why we care about application security in general. So if it's an application security issue at a vendor, then yeah, that's when it's going to hit the news and then they start scanning across the general internet. But if it's something specific to a bank or an industry, or nowadays IoT or IIoT, that I think is a little more specific, at least the way I'm thinking of it.
Well, I think one of your points, Clint, is interesting, and I'd love to get your thoughts on this. Some of what you're talking about is not up to the AppSec group. There's some shared responsibility here between the engineering folks, the developers, people in between, on secure configurations, and then actual bugs in code and, making sure libraries are sanitized and stuff like that. So how are you seeing those teams work together to, make sure the application as a whole is secure?
Yeah, that's a very relevant question. So I think one shift that I've seen is rather having like engineering and security as two like separate and sort of antagonistic forces, where the security team is trying to like force security on the engineering team. I think rather a number of security teams are viewing themselves as sort of the counterparts to engineering teams, and sort of how, your company's product has customers, like the people who pay you. I think I see a number of security teams referring to engineers and developers as their customers. So like, how can we, build things for them? And I think ultimately one sort of key insight I've learned from a couple of friends of mine at various companies is, how can we sort of build and invest in common capabilities that are useful, not just for security, but for engineering teams as well. So I'll give you like two examples. So one is, say, asset inventory or visibility. So there's a whole bunch of like asset inventory companies, security startups that are coming up that are basically like, how do you know all of the things you control, whether that's, cloud environment things or like various code hosting platform things. Basically, like, how do you understand your environment? So this obviously is useful for security, but also for engineering teams, right? Like, you want to know, maybe your finance department wants to know like what your cloud environment looks like, because that's like related to billing. You want to understand all the services you own and which team owns those, right? So visibility, useful for both engineering and security. Another thing, like what I've seen more firsthand, is like code analysis capabilities. So for example, like security, obviously you want to find bugs, you want to enforce secure defaults. So static analysis is one way to do that. But engineering teams also want like reliable, scalable code. Like there's maybe a developer productivity team or like an infrastructure team that develops sort of core platform things that many other teams use. And it would be nice for them to be able to enforce sort of secure defaults, or at least sort of robust or correctness defaults. So for example, maybe there's an API that like, you should always call it this way. It's not necessarily a security thing, but they want to enforce this sort of code property, or maybe they want to help developers get up to speed faster by, like, hey, you wrote some new code, but that's not how we write things here. We write it this other way. So I think being able to sort of find code matching a specific pattern and recommend like, oh, you should do it this other way instead of this way, similarly is useful for both engineering and security. So I think in any area, if you're like, oh, I want engineering to adopt this thing I'm building, think about like, how can I build this in a way that's useful for them? So maybe that's like adding in detailed telemetry or logging or some sort of performance characteristics or visibility into, I don't know, like performance characteristics. Yeah, so that general idea I've seen be effective at a number of companies. Not necessarily easy because it requires like working with other teams with different priorities and understanding what their needs are. But I think that is ultimately how you can get something adopted org-wide in a more effective way.
Yeah, it seems there would be a big cultural and leadership component there, because you'll go into the place where, you maybe ask, hey, is there, what language should I be using? Where do we put this stuff? That kind of thing. And they're like, well, that's why we hired you. You figure all that out. And then the place you walk into where they actually have some standards and like what you're talking about, maybe some training wheels for new folks coming in. Some guides and things like that. It takes effort to build that stuff. That's overhead. Somebody has to say, hey, we're gonna actually take the time to, formalize some of this. Put some polish on our processes here, right? Yeah, definitely. If everyone's doing everything differently, it's sort of hard to do that. But you don't always need to build everything from scratch. So, for example, you could say like, we have been having a couple of bug bounty or pen test reports reporting like XXE. So for the languages that we're using, is there like a standard off-the-shelf library or way to do that? So for a number of classes of issues, unless it's very bespoke, sometimes there'll be like an open source alternative, right? There's like RE2, which is like a regex library from Google that prevents sort of regex denial of service. So there's like open source stuff that's available. It's not 100% bespoke, but if it's like business logic related, probably it will be. But yeah, there's stuff out there. But yeah, I really like what you called out, which is there's definitely a huge people and cultural aspect. Like, can you get cultural buy-in to do things this way? And also, who are sort of the leadership engineering counterparts that you can sort of sway to your side and be sort of partners with?
Let me throw a thought out to the two of you to see if this sticks on the wall. We've got this. Oh God, here goes John. We've got this idea that people have been excited about over the last year of codeless. I saw over the last week or so, there's actually now an agency out there that specialized in doing codeless projects. And my thought was, if it's codeless, why would I pay an agency? Couldn't I write it myself? But from, just thinking about what you're talking about, Clint, if you have these snippets of code you're able to drop in around, or an IDE is able to recognize or something, you're getting closer to that concept of codeless, right? Not so much, and I say codeless here the way we use serverless, right? It's obviously not codeless, but if you're able to trust the smarts of other people to be able to make your code more secure, easier to write, less wheel rebuilding. I guess the comment I'm looking for around that is does that sound like something that's a reasonable thing to use that phrase, maybe codeless security, or a way for maybe some people in management to think about it? So it's still someone needs to do the work. It's not like a snap the finger and it's gone. But at the same time, if we can expect that through some sort of tool, we're making the developer's life not so much easier, but give them more confidence in the security of the application they're releasing.
Yeah. There's a ton to unpack there. Let me take no. There's a bunch of. I really liked your no code analogy, and I actually hadn't thought of it in that way or in that direction yet. But I think, I really like that idea. Let's see. Let me. So I guess to take sort of like a archetypical example, let's say code moves in this no code direction where there's a bunch of sort of blocks that are okay, talk to the database here, make this request to an external thing here, and all these sort of components say already exist. Yeah, and I think that is in some respects where we're trying to head, which is like, what are, for all the types of things you would want to do, what is the sort of secure by default way to do that? And if you're doing, like, let's say you've defined sort of good patterns for all these like types of things, then if you're only using these good patterns, then probably most classes of vulnerabilities you just like don't need to look for anymore, because you know by construction they just can't happen. And then you can start reasoning about like, okay, you're not doing any of these sort of contextless vulnerabilities. So now we can start looking at how like the various code blocks interact with each other and look for sort of like higher order types of issues. When I say contextless, yeah, like to be honest, a lot of vulnerabilities I think are pretty boring and annoying to me, because they are not specific to the application. They're just like, this is a bad coding pattern. So for example, like an unparameterized SQL query, a place where you're turning off output encoding, you're parsing XML without turning on like turning off external DTD loading. Like there's a set of things that like, if you just look at like the small snippet of code, you know that it's vulnerable without necessarily reasoning globally about various security properties. And I think that, as to your point, John, as we move toward this like no code or like more well-defined world, ideally all of those sort of localized issues that you can reason about very straightforwardly, ideally those just go away, and then we can focus on more interesting problems. But sorry, there was a second part. Can you remind me that I also wanted to mention? I think I only addressed like one of 5 things you said.
You're expecting me to remember what I just said. No, I mean, I think that's it. I think that the two thoughts were there sort of combined together, the way you're talking about them, and it's yeah. Excuse me, getting the buzzword incorrect. No code, not codeless. But yeah, that's. I think I'm a little surprised we're not seeing people move, or we're not seeing either the framework providers or the languages moving that direction. Thinking a little bit about what you were talking about earlier, with the languages and the frameworks moving from like the example you're using, I think with Angular with the React, to the more modern ways of doing that. The other example in there I really dig is when still provide the drawer of knives if someone wants to go and cut themselves, but name the functions to do that in such a way that even when the developer is writing it out, it's pretty obvious that they're about to cut themselves. So either calling the function insecure or calling the option insecure, it both allows the developer to learn and understand you're doing this, but it's probably not the best thing, but also allows either in a CI process or with SemGrep or a human being, when you're going through looking at the code, you can sort of spot where those things are being used a little bit quicker.
Totally. And I love that model of like naming the function dangerously do something, or like insecure do whatever. Yeah, I like that. And then I also like the idea of like, can we like, usually those like function or parameter names are like a bit longer, and I kind of like that they're longer, because it like takes you more time and effort, and like it gives you more time to like think about it. Like do I really want to do this? It's like 15 characters. Like, I don't know, I have to really want to do it to do it.
Yeah, when you jump into analyzing malware and ransomware and stuff like that, like a lot of most of the time, it's just like the function names are just A, B, and C. Like it's intentionally as obfuscated as possible. But I've seen actual programmers write code like that before, also.
More often than not. I tend to, as frequently as I can, make, and it comes from, I always talk about 3:00 in the morning, right? I want to be able to understand what I wrote 2 nights ago, but it's so common for me to see, so I'll use fairly descriptive names or function names or classes, but it's way too common for me to see people, use N in 10 different places. And then when they need a second variable, they use NN. It's like, come on, just use your words.
Clint, is there anything else we haven't covered that you really wanted to say or get across?
So there's actually this research project we've been working on that we've been sort of drafting this long blog post / sort of white paper about that isn't quite public, but I thought I could maybe tease it because I thought you guys might be interested.
Yeah, go for it.
Yeah, so basically, we saw all of these companies, Microsoft, Facebook, Google, Netflix, and others write about, this idea of secure defaults and how powerful they thought it was and how effective and high ROI. And we were like, okay, like we believe you sort of philosophically, but we kind of are very engineering driven. So we were kind of like, show me the data. Like I want to see if this actually works in practice, not just at these sort of FANG level companies. Can it be effective, for anyone? So what we did was we were like, okay, well, if we have this hypothesis that security defaults are effective, then in practice, in the real world, we should see sort of adopting them, or perhaps the lack of adopting them can lead to vulnerabilities, where if they had not done that, it would have not happened. So what we did was we basically searched GitHub for a number of cross-site scripting issues in real projects, real open source projects, and sort of collected them across a number of major languages and frameworks like, Python, JavaScript, Go, Ruby, and so forth. And then independently, we also basically reviewed the docs for all those frameworks and languages and said, like, okay, what are the ways to disable output encoding in these? So like, if you did this is like potentially dangerous. So we wrote a series of semgrep rules to say, hey, we see that you're disabling output encoding here. This is potentially dangerous. So we took all of the real cross-site scripting and real projects, and then took like our security checks for disabling output encoding. And then we sort of ran those on each other to see, how many of these real cross-site scripting vulnerabilities would have been flagged by just looking for like, are you opting out of security defaults? And I think we found on average like 60% or greater of these vulnerabilities could have never happened in the first place if you just flagged like, hey, you're disabling protections, like don't do that unless like you really have to. So we thought that was pretty exciting because it was taking this sort of idea of security defaults that, big companies with huge security teams thought was a good idea, but like, oh, this is actually, data driven, like actually very powerful. And also, we wanted to not just use like internal libraries specific to a company, but these are just like Ruby on Rails and Express and Flask and Django and like things that are just like, web frameworks everyone uses. So we found that it was quite effective in practice. And we also have sort of released these set of security checks that we did in that research. So, anyone can run it for free just by going to like we have like an open source repo that has the checks in it. That was something that we've been working on that we were, finishing like sort of the final blog post. But we're quite excited about it.
Awesome. Yeah, I'd love to see it. Is that is that separate from the semgrep rules?
It is sort of a collection of semgrep rules. So It's just more semgrep rules. Awesome.
Well, let us know when you release that. It'd be fun to have you back on.
Yeah,
talk about that specifically.
Yeah, I was hoping to have it done by this time, but it didn't work out, unfortunately.
That's okay. That's okay. John, anything else?
I think I'm good. Are you starting to think about traveling for talks or doing anything public yet, Clint, or are you still on lockdown?
I think I'll probably start the conference circuit again, maybe in a couple of months. I think we're going to start doing some talks and trainings. I don't know if I'm going to go to Vegas, but for Hacker Summer Camp, but I'll start. What about you guys?
I'm about the same.
Definitely.
I've got the people are starting to ask about, are you going to be at Hacker Summer Camp? And I'm like, we'll see. But I'm looking forward to getting out and seeing people in person pretty soon.
Yeah, I'm looking forward to it too, though I'm skipping Hacker Summer Camp this year. I'll be at InfoSec World, since that's a CRA event, and Security Weekly Unlocked in December. So I'm looking forward to those, both in Orlando,
nice,
as it turns out.
Look how he got
that. CFP is open. Clint, it's
okay. Yeah.
All right. Well, thank you very much for joining us, Clint. We are going to take a break, and we'll be back in a few moments with the news.